Hello, ladies and gentlemen. Welcome to our webinar series iTAC Live on Stage. Today we have the last session. We have to talk about today about new possibilities in the manufacturing through flexible production. But before we start, we want to introduce ourselves. My name is Jens Rick. I'm product manager, MOM in the iTAC software AG. With this, I have 5 years experience now. Before, I was working in iTAC as a technical project manager. I run a lot of international and national projects and get a lot of experience with these projects. So I saw a lot of requirements of the customers and turn it into solutions with them together. Yuri.
Okay, good. Hello, ladies and gentlemen. Also welcome from my side to our webinar session here today. I'm Yuri Ziegele, and I am a sales manager at the iTAC company. And since 2015, I joined this company, but before I joined the iTAC company, I was working at another company. It was an automotive supplier, and here I had almost 10 years time to make my experience and know also the situation very well at the customer side, and all the weak points, challenges are more or less known by my side. By me. So, but today is not, we will not talk about us, so we will talk about our topic of the webinar, and this is as it was mentioned by Jens, the flexible production.
Okay, thank you, Yuri. After our introduction, so we want to give you an overview where we are. So, as mentioned before, we in the live on stage session for the flexible production. So that's the last one of the webinar series. So there was a lot of interesting sessions. So you can find them if you're not be there on the live session. So you can download these videos of the sessions out from the navigation bar on the right side. Yes, today we talk about logistics and what the logistics should do or can do in a modern factory. Therefore, we have 3 use cases bring with us today. Mm-hmm. So the first one, we want to talk about material replenishment and the challenges and solutions. The other use case is talking about work in process and what the implementation of work in process logistics for into an MES and MOM world, what it will bring to you. At the end, we want to introduce a way how logistics can improve the production process himself. So that is the FLP case. I believe there will be a lot of questions while our webinar. So we open a Q&A session. So you even can find it on the right side. So if you have any questions, please drop them there. So we will try to answer your questions after the webinar. But even before, we want to know something from your side.
Okay, so we prepared the survey and for that case, and we would like to know if you have any experience already with transport control. And this is right now displayed in your window and on your screen. So please make your choice. There are 4 predefined answers, and we will be very glad to know which one you make your choice. So the most of you.
Okay. Thank you, Jure. I want to put this topic for today in the reference to our portfolio, what we are already developed in the past on iTAC side, what you may use. So even that was reflected in the webinars in the Live on Stage series. So, for example, in the medical session, so we have a deep introduction what the traceability and the shop floor connectivity is about, because in the medical you need to document everything, and it is of course a challenge to document it, but even to document it in an efficient way, so that you not slow down your production.
Yeah. Yes.
In another session, we had talk about simulation and order planning, and this one was also interesting because that is a point where you already increase the efficiency of the shop floor before you really start a production. Nevertheless, and what I mentioned before, I was impressed from the presentation what manufacturing analytics can do. So because I'm from the software, and the combination of machine learning algorithms and manufacturing analytics using data from machines and join them together with MES data to get more out of it are very, very interesting. So if you not see it yet, so you can access them from the navigation. Okay, thank you. Let's talk about logistics today.
Okay.
Yuri, what do you think? Why is logistics in shop floor important?
I would say it's important because how should the material be delivered to the workplaces, workstations where you would like to assemble some products?
Yeah. More in detail.
Okay, then let us dive more in these details. And the logistics is on the shop floor helps you to ensure the materials and products that they are transported in an efficient and cost-effective way. So I think this is the first thing. The next thing will be that the ideal logistics try or allow you to process to run the production without any problems very smoothly, and that means that the material should be on the right time, at the right place. So therefore, I think it's also very important try to reduce the storage space, the warehousing costs, and so on. But also don't forget to reduce the waiting time of the workers and also the machines itself. Furthermore, I would say that well-organized logistics improves also the productivity and reduce the overall cost in the company. And finally, I would say it plays a very important role in the optimization of the production processes and the saving of cost.
Okay, what's meant to us? Have you an example?
Yes, sure. Let me explain you just one, I would say, typical example. Recently, I was at the customer, and we walked through the shop floor, and we found there, and the machine was stopped. So.
Okay, so what means a stopped machine with the logistics?
Okay, but the reason for that stop was that the material was missing there.
Okay, I got it. So what you want to say is, and what I agree, definitely. So the MES or MOM system should have also an information, a look through the material situation on the shop floor.
Yeah, that's right.
Okay, so let's have a look where we can find logistics in the shop floor.
Yeah, if you would like to assemble somewhere.
Okay,
Yeah,
so
something somewhere, yeah.
to bring the material to the assembly.
Yeah, to bring this
replenishment.
yeah.
Okay, what about between the production lines, between the processes?
Yeah, sure, there as well.
Yeah. Yeah, I think the points are made. So let's have a look in details what the iTAC MOM suite have already on board to support you in these cases. If you heard the word logistics, or the people heard the word logistics, so most of them they think about the truck on the road and what they have in terms of traffic jam. But we don't want to talk about traffic jam today. We need to talk about logistics in the shop floor. Yes, logistics in the shop floor is mainly to bring the material to the process to execute and to solve the logistics needs between the processes. But you will fully agree with me, in this moment, the most thing in these processes are efficiency.
Yeah, indeed. So I think it's not only one solution.
No, it is not.
Yeah.
As every customer build different products, have different processes, they need solutions they fit to their needs. So our way is to work together with the customer to define logistic solutions so that they get the most out of it. And that is what we want to show to you today. So in our 3 use cases, we will talking about this replenishment process, CRP, this WIP transportation between processes, and of course this flexible production case.
Okay, then let us dive a little bit more, one by each use case. And we will start with the replenishment.
Yeah.
Yeah, but I would say what I understood what replenishment means is that the replenishment cares about the worker that it should and has enough material at the workstation so that he can do the work and assembly, for example.
As simply as is, as complicated as it is. Okay, let's recap. You know the main methods of replenishment?
Yeah, it's a long time that I've learned it, but let us recap it and take a look on it. So, so we see 3 different methods of replenishment, and one of this, the first one is the inventory-based replenishment. It's based on monitoring of stocks level and order quantities.
Yeah. This is mostly used in processes where I have kind of static production. So where I not have any variance, so I know what I'm doing tomorrow or in 10 years or whatever. So, I mean, I just have all the material on the shop floor and time by time it's checked and it's refilled there, yeah?
Yes, that's right. So it's based on the threshold. As soon as it's exceeded, then the refill, the replenishment will be triggered to, the material should be replenished. So, and another method is the pull, and here it's based on the actual demand for materials. So that means really what will be required in the shop floor that will be also delivered there.
Yeah. So mostly we see this in a way so that based on a production plan, all the material for a day or a shift will be prepared in the warehouse and then sent to the shop floor. So it's a kind of push principle, yeah?
Yes, that's true. So, but here is also one, I would say, issue. So you should somehow try to, or to, yeah, to avoid the overstock in your shop floor.
Yes, that is, of course, that's always the goal, right?
Yes.
But
Yeah, this is the goal. So, but then the fourth method what we have is the Kanban, and this is based on the so-called Kanban cards and Kanban containers, and it's very simple to explain. If one of the containers is going empty, you need just only to replenish or to refill. That's it.
okay, but I think Kanban everyone knows from us. We don't need to explain more about.
Yeah.
Don't waste time. So let's diving more in details what we can do when we put everything together with the iTAC MES suite with all the information what we have. So, okay. If we think logistic and the shop floor, and we talk already so that we have space problem. So you will agree if the logistic is not efficient, so we have to compensate it with other things. Yeah. So yeah, simply said, if I'm afraid that I'm running out of material, I'm doing some stock material on side of the production line.
Yeah, yeah. You mean the huge space just only for the buffer?
Yes, production buffer. That's what I want to say. So, but the production buffer take the place from the production. So, if you compare by area, so the production gets inefficient. Yeah. So, if you have better logistic, you can pack more production power to the shop floor. But on the other hand, even logistic have other requirements to fulfill. So some material have special needs. So I thinking in the electronic we often find this issue about material lifetime, shop floor lifetime, MSL. Yeah.
Okay, so you're talking about the MSL relevant materials, but what can improve? Yeah, what can CRP do better as the another methods what we mentioned before as the CRP system? So
yeah. So as we said before, so we have active or reactive principles. Yeah. So if you have this active principle, so that I have all my productions orders of the day and I send all the materials to the shop floor, I can consider changes, or I have problems to consider these changes. We following the idea that we are trying to be reactive on this way. So as you can see here, usually it should be easy to calculate when material runs out on a work cell production station, based on cycle time and consumption, and you can calculate when it gets empty. And if you just take a little bit time buffer in consideration, you usually have the point in time where the material to refill needs to arrive on the station.
Okay, but what do you mean exactly?
Yeah, what I said was the perfect world.
Yeah.
But perfect world get always interrupted. So we have problems all the time with something, the machine breaks down or whatever, yeah?
And what is the magic of CRP?
Yeah, to step out of this perfect world, so we need to do a little bit more. So, as you said, our magic. What we said in a perfect world, so we can do already with the data we collect by our traceability module. With the traceability module, we have the view into the shop floor. We know what is the current production order, what is the remaining quantity, what is the remaining quantity of the material, what is the cycle time for now, and of course what material we need. So even if there are some disturbances, we even can recalculate this point in time very easy. But sometimes this time horizon is very short. Yeah, so it is always better to look a little bit more further in the future. So that is what we said. The next element is to take the scheduled orders in consideration.
Okay, so that means the scheduled orders can be also scheduled and planned and optimized with the APS.
Yes, so that is where our APS comes in place. So the APS even have a look to the shop floor and reconsider the schedule based on the situation there. So that is the first point where normal logistics steps out, because we know this fine planning. So we know exactly what should be the next order or next order on this production line or the station. If we have this information, so we have a very good overview of the near future time horizon to do this material replacement planning. Another brick is that we need to know where is this material located, what we have to bring to the shop floor. So there our ML module is very helpful, because the material is stocked somewhere in the warehouse, and this information we can consider based on transportation times. We know to calculate when we need to stock out the material there to bring. Yeah, and nevertheless, yes, the CRP even need to consider what is already on the way.
Okay, so that means it monitors also the already the material which is in transport, right?
Yes, that is the point.
Yeah.
You know, my lovely word of the day, it will be transparency.
Transparency.
Yeah, so we have this, with all these modules and with the status of the CRP, we have built this transparency, and with this transparency we have the overview, and we can do an planning, and we can have a reactive planning, what we're doing with the CRP. But what I want to highlight is nobody wants to run to the warehouse by a single screw to pick up there.
Okay, so and that means all the materials what will be required at the the dedicated period should be a specific time slot should be delivered at once. At once.
Exactly. So the transport control, what is the foundation for the transportation in the iTAC MOM suite, can not only handle transport orders, we can even group this and wrap these transport orders to tours. So in this moment, what you mentioned, we can bring wrap all these transport orders into this periods. Yeah. So and that is able to configure even to the customer needs in this case.
Okay. So then let me summarize.
Okay, thank you.
Okay. Then let me summarize what we've heard about the CRP. The CRP here is an add-on to transport control to supply the material in the shop floor, and it helps to create the transport orders based on current production situation. Okay, and it manages the transports with more precise information on time, where it should go, also place, the quality, so and also the quantity itself. So, and it controls also all the transportations and the transport means. The classical one is the forklift, for example, or manual transport tools. But also it can help to control also the modern transport means like AGV.
Exactly. Okay, thanks for this very good summarization.
Okay, then let us dive into the WIP. And now we talk about material in the shop floor. And yeah, the material right now is used and mounted. And what is the next?
Yeah, so as we said, so the material is mounted, and we are built products or semi-finished products. And even that should be a part of the logistic in shop floor.
Okay, and you mean here the WIP, the work in progress.
Yep.
And this is the this is the it refers to the status of semi-finished products, which are right now or still in the shop floor for the forward processing or for forward processing.
Yeah. In a classical landscape where we have an MES, where we have a logistic module or a warehouse management, what take this logistics process into account, semi-finished goods disappears.
Really?
From MES point of view. So, so if the product leaves the process, it really disappears. It's not visible anymore for the MES until it appears again in the next process or in the warehouse.
Okay, and that means you mean warehouse. So, then all the data will be present then in the ERP or in the in the warehouse management system, right?
Yeah, correct. But in the other times not. So that is a gap, yeah.
There is a gap, and that means you are blind there.
Yeah, and blind is money.
Yeah, that's true.
Okay, you will agree with me. The target is to have all the time transparency. I mean, we need to know where the goods are so that we can control it.
Okay, yes, and how it can looks like, I will show you in the demo. And just only one info here, we already recorded this demo before that you will see right now. With the demonstration of the WIP client application, which you can see here on the right side, I would like to explain you our use case, which is displayed in a graphical way and explains in a graphical manner. And this is a typical case what you will find in the shop floor. You have one sub-assembly station, and another one is the final assembly. And at once the semi-finished products have been completed at the sub-assembly station, a transport order with a tour is automatically generated for the batches. And that will be done by the transport control service, which is running in the background. The tour has a start point and end point. In our case, is the pickup and the delivery station. And concrete, and this means that we have to pick up 2 batches at the pickup station and load onto the trolley, for example, and transport to the delivery station. As soon as the tour begins, the timer will record the transportation times, and from the starting to the starting point to the end point. As soon as we arrive at the destination station, we have to unload the batches from the trolley. And as soon as it's done, the tour is ending and the transport order is finished. Okay, now we will start with the demonstration itself. of the work in progress client, which you see here on the right side. Now you see that I'm already logged in, and the user interface, what you can see, is adapted to my profile, and the profile can be maintained in the iTAC MOM suite, and also the registration data can be also maintained in the iTAC MOM suite or transferred via the LTAP service, what we offering as well. Then let me select the WIP transport, as I mentioned before. Now you see the tours which have to be processed by the logistics operator. So so as I explained before, once the batches are completed and ready, the transport control service generates the transport orders with the corresponding tours and segments. And this is what is displayed here in the WIP client. Furthermore, it shows where the semi-finished products have to be picked up and where they have to be transported.
Okay, let me recap. A tour contains pickup station where we load the batches, and the delivery station is where I have to bring it, correct?
Yes, exactly. And or just it could be also several pickup stations or stop points on inside the tour. But please be aware, the pickup or the destination can be also a location somewhere in the warehouse. Therefore, in general, what can be also said about the WIP client and the application is that you will be guided through the necessary steps by displaying the corresponding comments and descriptions, and it's what the employee has to do. He has only to follow the messages that are displayed on screen of the application.
Sounds intuitive, and I guess new employees in the shop floor can be trained very easy, huh?
Yes, exactly, and that was really the purpose of it.
Oh, good.
The starting point, let me select right now the one of the tour in the list. After selecting the tour, you will be asked to scan the barcodes of the batches. This is what we will do. You need just only to activate the barcode. Then, as you see, the first batch were accepted, verified and accepted. If the wrong product will be scanned, it will be denied. Now we scan the second batch. So it was also accepted. That's fine. Now we need just only to confirm that the batches are loaded on the trolley, for example. So now the transportation is started, and also the timer for recording the transportation times is also started.
Yuri, I have a question. So how the employee knows where to bring the stuff?
Yeah, it will be displayed as an image in the WIP client, as you can see it right now in the middle of this screen here. It can be easily done by configuration the iTAC MOM suite. That means with a few clicks, the corresponding images will be assigned to the stations, and the WIP client will display them on the screen corresponding to the location.
Nice. Helps a lot, I guess.
Yeah, it's very helpful and useful. So, and when you arrive at the destination, you have to scan the number of the delivery station, and it will be also verified that you arrive at the right one. Now we will do it. Okay, it was accepted that I arrive at the right station. Now we have to scan the batches, which will be unloaded here at that station. And this is what we will do by scanning. And we did it with one batch, now with the second one. Now we need just only to confirm that we unloaded the batches at the right place and location. And if no more tours and segments are displayed in the web client application, the tour is completed and the transfer job is done.
Oh, time for a coffee for the operator, right? Nice.
And that, yeah, indeed.
Okay, Yuri, thank you for your presentation. Let me recap what I learned in this web use case. So, as usual, so my lovely word of today is transparency.
Yeah.
Transparency brings us as well then the reduction of cost. And we even have potentials for the future. So if we are going in the collection of transportation times, we have the potential even to optimize our shop floor logistics in the future as well. So it was very interesting. Thank you, Yuri.
Okay. Then before we'll jump to the next topic, so okay, good. Now we have seen how the manual web transport, how it works.
Right.
So, but is it possible to do it also automatically?
Yes. So we call it FLP.
Okay. And what does it mean, FLP?
FLP stands for flexible production.
Okay, again, question.
Okay.
What is flexible production?
Flexible production. Yeah, back to the roots. So in the beginning of industrialization, so they find out that I can building products much easier if I bring them to an assembly line. So rigid conveyors give a throughput, so I can very easily assemble my products.
Okay, but that means it's like the, I think, very well-known principle from Henry Ford.
Exactly. So it was very easy. So always the same products, day on, day off. Yeah.
Okay, but if you're producing always the same cars, so that means in that case was always, you mentioned that you can have every car as soon as it's has a black color. So
yeah, exactly. So always the same products, very easy to assemble.
Yeah.
Bring them on an assembly line and go. Today the world is different. So even you will know it. It's getting more complex. Mostly we have products with a high individualization.
okay, and which impact has the individualization in this process?
Yeah, usually I design my process so that more or less all the products are running to the same process. But even if I have this different of products, so I have at the end an high product mix.
Okay, but more details, please, here.
Yeah, this high product mix means my production line needs to be or is limited to the product with the lowest cycle time.
But that sounds not good.
No, usually I'm losing efficiency with it. So
Yeah, but you cannot do it with a static assembly lines.
yes, so if you do it with the static assembly lines, you have to live with it. So the better case would be I can even do this transportation more flexible, and that why we have this idea to combine modern designs, what's already known on the market, for example, replace the static conveyors by AGVs. So it's a little bit like times before Henry Ford. So where we have a manufacturing one by one in certain work cells, yeah?
Yeah, that sounds good, but yeah, can you explain it a little bit more better in the details? This is what we need here. So
if I'm cut the static conveyors and introduce this new digital concepts to control this AGV, this automated vehicles, I can use this to get dynamic and flexible transport solutions. And if we pack it or assemble together in a kind of system, so even we get the benefit to easy adapt to disturbances, yeah, and we get transparency.
okay, and all that we can do with our FLP solutions?
Exactly. Let's have a look. We have the in the assembly world we know that we are building products based on a routing or on a work plan, yeah. So what we miss is the gap. We miss the gap between process to process. So, and of course, with this static conveyor, so it's very easy, just moving, just driving, and it's coming to the next process. But we learned already what is the disadvantages in the modern times for it. So if I reduce this disadvantage by removing this static conveyors, and I put in the flexibility of AGVs, I need to control them. So that's why we are describe this or set up as a traveler.
And why you use here the traveler?
Yeah, as said before, so the traveler represents the time between these processes, between the stations.
Okay, so but that means if something is going wrong, what you will do here?
Yeah, as usual. It's just a matter of time if something goes wrong. Yeah, a product can have deviations, so it needs to rework, for example. And that is where the main difference between a work plan and the traveler is.
I see.
In a work plan, if the product is not built correctly, is not leaving the work step. So as long as not reworked, we cannot go for the next process. But I see the question marks in your eyes. For the material flow, for the traveler, it's different. So I mean, the product is the process is finished with an not good result, and we need to decide where to go. So we cannot go for the next process. We have to go for a different location. For example, a rework station, or everything goes wrong, maybe for a scrap.
Okay, I see. But you always start with any process step, right?
Exactly. So, but we are starting always when a process is finished, and we need this result into consideration, either to just drive forward with a predefined next process step, similar like in a work plan, or we have to readapt the traveling. So then, now you see the main difference. Maybe instead to go further to the next process, we need to go for the rework station. So we have to adapt the schedule to drive to a different destination. So the traveler must be flexible, otherwise we cannot do so.
Okay, so that means the traveler reacts on any deviation and any changes in this traveler.
Yeah.
The traveler reacts on this situation. Yeah.
Exactly.
And that means it doesn't matter if the part is scrapped or reworked, whatever it is, then you do it on the fly.
Yes. So I think you got it. So the work plan should be really described. What are the sequences of processes we go? The traveler need to have the flexibility for transportation. So we cannot do it with a work plan. So that's why we have this travel inside. But interesting is, and I think you got it already. So we are starting always with transportation when the process is finished.
Okay, and that means you started with and initiate in transport,
Yes.
but you do not know to which station.
Yes.
Okay.
Yeah. Yeah, it sounds weird, I know.
Yeah, very dramatic.
Yeah, we are start driving because we don't want losing time. So while we are driving, we using this time to distinguish, to define the exact delivery point, the exact station of the next process. So, and this we do as late as possible.
Why as late as possible?
Yeah, my second word of the day, something goes wrong. The point is, the driving still takes time, and in this time maybe something happen to the target station if we define the station before.
Okay, you mean that the right material is not there, or there is a tool which is not available, or any other,
or a single breakdown, yeah.
or single breakdown. Okay, good.
So, but your question already brings me to the next point. Yeah, not only processes might be to take in consideration to define the right station. Maybe even other parameters are very important for the customer to implement. You mentioned maybe we need to have the right tool for the product to build, or the right material on it. Such thing could be easy to take in consideration, because this decision making we realize already with iTAC low code.
Okay, so that means you can easily adapt the customer specific use cases in this FLP solution.
Yes, so it's part of the customization process. So inside the customization, we are adapting the FLP processes, or the FLP elements to do the decisions as it's required by the customer.
Okay, and which added value I will get it here?
Of course, even there's some other added value. So, and what I want to say, transparency.
Yeah.
Yeah.
I think we heard it many times today here.
Yeah, this transparency is important. So everyone knows the customer wants to see where is my product.
Okay.
And that's here and now.
Okay.
So
then please let us show this. Let us
Yeah.
see how it works.
correct. Thanks. We also have a presentation prepared, what we want to show to you now. The user interface of the flexible production. This is a SCADA interface which provides all the information of the FLP to the operators in the shop floor, as well for the management. In the middle of this screen you can see a high-bay storage. That high-bay storage contains car bodies, and the car bodies will be extracted from the high-bay storage based on a product mix. The product mix is necessary to balance the production in the shop floor. When a car body appears on the outlet of the high base, it calls an AGV from the waiting lane. when the car body is loaded to the AGV, car body and AGV gets a union.
That's like a taxi service.
Yeah, it's like a taxi service. On this SCADA interface, we have all the time all the information available about the AGV and the car body. But you have to know, the driving of this car bodies is managed by the fleet manager. The fleet manager knows the topology of the shop floor in all the details.
So, with start and end point.
Correct. But the FLP gives the transport orders. The transport orders are managed in the transport control. Transport control also need to know the topology, but not in these details. The final destination of a car body will be calculated while the AGV is driving.
And this closes the circle.
Correct. On the other hand, even the fleet management provides his information back to transport control and FLP, so that all the informations are coming to this SCADA interface. With a click on a car body or an AGV, we get all the informations. You can see here that this car body comes from station 101 and need to go for destination 501. So that is the destination process. Later on the driving, we calculate the exact station where it goes.
And that means we have a full transparency.
We have the full transparency of it. But not only the full transparency for now, but even for the history. With all these informations, by clicking here, I can see what is the history for the traveler, for the car body, as well for the AGV.
Presentation for demonstration of the...
Thank you.
Okay, then let me summarize what we have seen and what we discussed before. So the FLP is a dynamic and automatic control tool of the material flow. And transportation of the products to the various processes will be done by the AGVs, which will be controlled by the FLP solution. Or the information will be provided from the FLP solution. So here, of course, what was also considered in the decision of the AGVs where they should to go is the availability and the capability of all individual stations. And based on this information, what we collecting all the time, and we can optimize the transport itself. So therefore, it brings also a lot of benefit. It will optimize the production utilization, especially for the highly flexible and complex processes. And to help or the iTAC low code solution, which will be also additional add-on, can help here also to realize and easily adapt the use cases from the customer. Is this correct?
Yeah. Good summarization, Uri. So we are on the end of our webinar now. So it was nice to introduce you our solutions for the logistic in the shop floor. And before we are changing for the Q&A session, there was something we was asking you. So, Yuri, can you...
Yes, it is. So the question was here. We ask you if you use any transport control tools to optimize the material replenishment process. So, we have right now the results. So for the first answer,
No, I think important is
no, the important is to say that so around about 43% of you voted for the that you already use the control, transport control tool, but without interactions and with the MAS world.
Yeah, so I think you see already there's some potential, and I'm very happy that already 40% use it already. So that is what I want to mention, yeah.
Yeah.
And but even there are other voters, though I think there's already some interesting interest in implementation of such a tool in the shop floor. So, as we are running out of time, let us switch to the Q&A session.
Yes, let us do.
And hope you give us a lot of questions in this moment.
Okay, then let us check.
Okay, let's see. Okay.
Okay, let us start with the first one. Yeah, the question was, in which languages is the web client available? Currently, it's available in German, but it will be not an issue to adapt it to any another language.
Yes, for sure.
Yeah, I think. So let me jump to the second one. And the second one was the...
Which mobile
which mobile device can be used to access current information on the shop floor itself? Yeah, currently this is an APK which is installed on the Android device.
Yeah, but what my experience with the customer is, there will be not that special application. So mostly, as we are starting in the beginning, what you learn is we need to adapt to your needs. So technically, what we see today was an Android application.
Yeah.
And even that was developed together with the customer and his needs. So, but we're supporting any OS or other devices. So our home and turf is HTML5, but as you see, that was an Android application, what you find in the leading scanners in the market.
Yeah. Then let us jump to the third question. Yeah. Which means of transport? Oh, transport. Yeah. Which transport means can you connect in your software?
Okay, very interesting question. So the design of our software is based on modularity. So or service architecture. So we are break it down into a transport control and other modules because of it. So the idea is that we not want to connect to just one fleet manager or just one solution. So we have open interfaces and can connect by these interfaces to, let's say nearly any fleet manager. And fleet manager himself needs to connect to other world as well. So you can do it.
Okay, but I think we have also...
Yeah, last question, I think. So
yeah, just only one question. We are running out of time, yeah. So, which one?
Yeah, so I think this is a good question. So can I integrate transport control into my existing MES suite or MOM suite? You have to know transport control is available already with iTAC MOM Suite 10. So there's the first version of the transport control. Okay, so I think we are nearly on the end of our Q&A session. So there are much more questions on the list. But yeah, as we are running out of time, we will contact you directly in person to answer your questions.
Okay, many thanks also from my side, and thank you that you joined our webinar session.
Yeah,
and hopefully, if you have any questions or whatever, you can also write email to us, the email address is displayed here right now on your screen.
Yeah, and the other webinars are still available for download.
Yeah.
So you can find it in the navigation here or on the website. Thank you and have a good day.
Good day. Have a nice good day.
Bye.